Unit 7, Day 4 notes. Today we're going to talk about angles of elevation and depression. An angle of elevation is formed from a person or item and when they look up towards another object. So the angle of elevation is you take the horizon, whoa, not literally take the horizon, and the angle formed with the horizon and you looking up at the object. So that's why this is the angle of depression, because you look up here, there's the horizon, and so that angle that forms those two, that is in the corner of those two lines, is your angle of elevation. And think about it. An elevator, or when you're elevating, you're going upwards. So use that to remember. Angle of elevation is when you look upwards. Now, depression, when somebody's depressed, they're down. And people who are depressed look down. So the angle of depression is formed by the horizon and looking downward. So this would be the horizon, the horizontal. This is when you're looking down, and the corner that joins those two is your angle of depression. Okay? The angle of depression and the angle of elevation will be congruent. So here's the angle of elevation. So if I were to drop this down and form a rectangle or a square, then again, the angle of depression and the angle of elevation would be congruent. So if it helps you, so that you get the angle in the right place, form a rectangle just as I have done. Draw the diagonal, and then if you can always remember angle of elevation, draw that one, and then on the opposite side you can put the depression angle. So you might want to get in the habit of drawing both, just to be on the safe side, and then label your picture according to what is being described in that scenario. So a lot of these problems we're about to deal with are word problems. So if there's not a picture already drawn, it's very helpful to draw a picture and make sure you draw it correctly. So we have a man standing on a horizontal ground 30 meters from a tree. So let's draw my man. And that represents the horizontal distance, and then we're going to have our tree here. Okay, so I'm going to label this 30 meters because that's how far the man is standing from the tree. The angle of elevation to the top of the tree from his eyes, so his eyes would be up here, right? On his head, of course. So let me draw my horizon. And then if his eyes, he's looking upwards to the top of the tree. And this corner right here would be the angle of elevation. So you always have to have your horizon. The horizon's not going to be the ground because the horizon has to start from his eyes. It's a person. So keep that in mind. So there's some extra height not being accounted for. So this angle of elevation is 28 degrees. We're going to estimate the height of the tree. So we're going to call this X. All right, so when you look at it, here's my right triangle. Okay, so we know the horizontal distance to the right triangle, again, is going to be 30 meters because that's how far he is from the tree. And then x, the height of the tree, we don't know, but in relation to the angle, x is opposite, so we do know that much. And 30 is adjacent. So we have the opposite side and the adjacent side to our reference angle of 28. So that means we can use tangent, the tangent ratio to find x. So we know that tangent of 28 degrees is going to equal opposite, which is x, over adjacent, which is 30. And now we're going to solve this trig function. Same way how we did on day 2. We're going to put the trig function over 1, so tan of 28 over 1. And we're going to cross multiply. When we cross multiply, we would have x is equal to 30 times tangent of 28 degrees. Now on a spiffy TI-84 calculator, you can put 30 times tan of 28 degrees all in one line in one step. If you don't have a spiffy TI-84, then you have to do it in multiple steps. So without the TI, you would have to find the tangent of 28 degrees first. So let's find the tangent of 28 degrees. Oops. Oh gosh, what did I do? Let me undo that. There we go. Sorry. So on a normal calculator, 28 and then tangent is about 0.5317. And now we got to multiply that with 30. And you'll get 15.95. meters, since we know the units. Now, to be honest, this problem is technically missing some information because we would need to know how tall the man was in order to truthfully account for the height of the tree. But since we don't know, and this is all we can use, we'll just leave it as is. So we're estimating the tree to be 15.95 meters. All right, and the next one says, an observer in a 55-foot tall lighthouse spots a ship in distress at an angle of depression of 9.5 degrees. So I'm going to have a lighthouse. Okay, with my light coming out. And it's 55 feet tall. A ship is somewhere over here floating away. So the angle of depression. Again, the angle of depression is formed by the horizon. So I need a horizon. And when you look down, so the man is looking down from the lighthouse to the ship. So the angle of depression is in this corner here. So let's label that 9.5. It goes in this corner. I don't have room, but it's supposed to be in there. 9.5 degrees. So if you were to complete your triangle, here it is, where it is intended for, like I said, you can make a whole rectangle, and this would be the same measurement, 9.5. So here would be the right triangle again, where the side across from it is 55. So 55 represents the opposite side. We're looking how far the ship is from the shore. So we're looking for the horizontal distance between the lighthouse and the ship. So we're looking for here, which is adjacent to my angle of elevation, or the angle of depression. So since we have opposite and adjacent, again, we're going to use tangent. So tan of 9.5 degrees is going to equal opposite, which is 55, over x, which is adjacent. Put tan 9.5 over 1, and now we cross multiply. And then you would get 55 is equal to tan 9.5 degrees times x. I forgot my x. I'm going to put x back in front. Now we find the tangent of 9.5 with the handy dandy calculator. It is 0.1673. And then we divide that on both sides to get x by itself. So x is going to equal 55 divided by 0.1673. 55 divided by 0.1673. About 328.75. 328.75. And we're in feet. 328.75 feet. I will help you draw the picture of this one, but then I'm going to need you to set it up and solve the question. So we have an airplane that takes off 200 yards from a building. So I need an airplane and a building. So I have my plane. Kind of It's like I don't know what that is. It didn't quite come out like I was expecting. But here's my building. All right. And the airplane is in front and it's 60 feet away. It says, I'm sorry, rewind. Where is the eraser? All right. So the airplane is 200 yards from the building, and the building is 60 feet. First of all, it says yards and feet, so I would have to do some conversions. There are 3 feet in 1 yard, right? So if I have 3 feet per 1 yard, how many is 60 feet? How many yards is 60 feet? So that would be 3x equals 60. So divide by 3. So x is 20. So this is 20 yards. We want everything to be the same units. I could have converted the 200 into feet and it would have been fine, but I need it to be the same units at the end of the day. So 20 yards. Alrighty. Now, it's asking for the angle of elevation. So the angle of elevation is formed by this horizon and looking and going upwards. So it's going to be this corner down here. We don't know what it is, so we're going to call it x. Now, when we look at from x's perspective, we have the opposite side, which is 20 yards, and the adjacent side, which is 200 yards. So that means, again, we're going to use tangent. Hint, hint, wink, wink. But we're looking for the angle. So tan of x is going to equal 20 over 200. Now, if you remember from yesterday's unit, or the last lesson, in order to find the angle, you have to use inverse trig. Now finish the problem. All right. As observed from the top of a lighthouse 100 meters above sea level, the angle of depression of a ship sailing directly towards it changes from 30 to 45 degrees. Determine the distance traveled by the ship during the period of observation. Ooh, this is a lot going on in this one problem. So, first, since I'm no artist, I know I'm dealing with depression, right? So here's my horizon, and that's looking downward. So this would be my first triangle. This is when you first spot the ship. So the first angle, again, was 30. So this is 30. And the lighthouse is 100 meters tall. So that would be this distance also. So this is 100 meters. And then the boat is going to move towards the shore. So let's say here's my new boat position. So the new angle is 45. here's your new triangle. Okay. Again, the height is still 100 meters. So at the end of the day, you're going to have two triangles, right? One where it is 30 and this is 100. The other one where it is 45 and this is still 100. Now, we need to find this side. So I'm going to call this one X and this one Y. And then we're going to need the difference between those two as our final answer. So let's get started. So this is opposite. This is adjacent. So it's tangent. So the tangent of 30 degrees is equal to 100 over adjacent, which is X. For those who can cross multiply quickly, what's going to end up happening is you're going to take X is going to equal 100 divided by 10 of 30 degrees. So with a nice nifty 84 calculator, you can put this all in one step, but I don't have one to show you, so I'm going to do it in multiple steps. So I need to know what the tan of 30 degrees is. But before I grab my calculator, let me set up the other one so I can do it at once. This one is also going to be tangent of 45 degrees now, which is 100 over y. So again, if I cross multiply and divide quickly, y is going to end up being 100 divided by 10 of 45. So again, I need to know what the tangent of 45 is now. Now I'm going to grab my calculator. So tangent of 30 will be first. And that's 0.5774. 0.5774. Let me write that down before I forget. 0.5774. And then I'm going to find the tangent of 45. Which is 1. Well, that's nice. That makes the second one a whole lot nicer. So that means y is 100. We still have to find x. So 100 divided by 0.5774. 173.19. And at the end of the day, we have to find the difference between the two distances. So during the period of time, the ship traveled 73.19 meters. That was a long problem. And that is it. Please take a picture of your notes. And that concludes our lesson.